Morning, Eicher's class. Good morning. Today we finished net and surface area. Can you identify the net of a 3D shape? Yes. Can you find surface area? Yes. What is a net?
A flat figure that can be folded into 3D.
So a net is something that's flat that can be folded into 3D, right? Yes. Okay. We're going to skip all of these things. They're actually super duper important, but we'll come back and kind of look at least a couple of them in a second. Surface area. The surface area is the total what? Area of?
3D surface.
Of what kind of shape?
3D shape.
Okay, so this is a net right here. Imagine your water bottle, or imagine a water bottle that has been flattened. Can you see if I folded this circle, and this triangle up into a 3D shape? Would that make a cylinder?
Yes.
The top of the water bottle, the bottom of the water bottle, and then this rectangle actually makes the body of the water bottle, right?
Yes.
If we folded that in, would it make an ice cream? Or we folded that all up, would it make an ice cream cone?
Yes.
Triangle makes up the cone if you fold it, roll it. Cube? Yes?
Yes.
Kleenex box?
Yes.
Because a Kleenex box really can be a what? Okay, cool. All right, so really then, to find surface area, we take a 3D shape and we just find all of the flat faces area, yeah? Right? So this one, I know it's kind of half shaded in. We found the area of this orange piece by using the base of 6 and the height of, what's the height here, guys? Oh, we got to look over here for the height, right? So we have 6 times 7. And then again, I'm just doing part of it right here. We had to find the area of this particular rectangle, which makes the top of the Kleenex box, right? What are the dimensions? What's this dimension right here? 6? What's this dimension right here? Well, it's got to be the same as this one. It's got to be the same. Oh, it's 3, right? How about the backside? What is the base of this backside? What's the base?
3.
It's 3 again. What's the height? 7. Now you'll notice I have 6 different multiplication problems over here, right? How many faces does this thing have? I'm going to say that again. I have 6 multiplication problems over here, right? How many faces does this thing have?
6.
I'm literally finding the area of every single shape that makes up that 3D rectangular prism, yes? Now, I only did 3 of them. I did this one, and this one, right? But we also have the one in the front, the one down here in the bottom, and then this one here on the side, yes? All of those you find the area of, and then what? I add all of these areas together, and that's where I got 162 units squared. Make sense? Question. How many faces does this thing have? Would you agree that these all right here are the faces? I literally broke them apart, right? And I found the area of each one of them. And then Aman added them all together for us, right, Aman? And that's how we got our total surface area. True?